Now that our link aggregation is working, we need to put the PCs into the right VLANs. So on port 1, on the first core switch, port 1 needs to be put into VLAN 2. On the second core switch, port 1 needs to be put into VLAN 3. So I'll telnet to core 1, log in with my username of admin, password of HP, type system view, display VLAN. At the moment you can see that only one VLAN has been configured. So I'm going to type VLAN 2 to create VLAN 2. I can give this a description of, let's say, blue VLAN. I'm going to type quit. I'm going to create the layer 3 interface immediately. Now you wouldn't typically need to do this. This you only do on core layer 3 switches. So interface VLAN 2 IP address 10.1.2.101. Display interface brief. As you can see, gigabit 101 is up, and that's the interface where my user is connected. So, system view, interface, gigabit 101, port, link, and in this case we're going to specify type, and we're going to make the type access. This is an access port. That is the default. So if I type display this, you'll notice that the command doesn't display. The link mode displays, but not the link type, because the default is access. Now to put the interface in the VLAN, you type port VLAN 2, or rather port access VLAN 2. So display this. You can see that this is a access port. That's the default configuration, and you can see that the port is in VLAN 2. Now my PC has already been configured with an IP address of 10.1.2.5. So let's see if we can ping the PC. Ping 10.1.2.5. As you can see, the ping succeeds. Let's do something similar on the second core switch. So telnet 10.1.1.102. Login as admin and the relevant password. You can see that we're on core 2. System view. VLAN 3 will allow me to create VLAN 3. Description, red VLAN. Interface VLAN 3. Allows me to configure the layer 3 information for this VLAN. So the IP address is going to be 10.1.3.102 with a /24 mask. Display interface brief. At the moment there's a problem on the switch. The PC should be connected to gigabit 101, but the interface is down. So I'll go and check the cabling, but for now let's put the interface into the VLAN. So interface gigabit 101, port, link type, access, which once again is the default. Port, access, VLAN, and in this case 3. Allows me to put that port into VLAN 3. So I'll need to go and check the cabling, but hopefully we'll have the same result. I'll be able to ping that PC once the cabling has been sorted out. In the meantime, let's see if we can ping from our PC 10.0.0.249 to PC2 10.1.2.5. So on my local PC, ping 10.1.2.5. As you can see, the ping fails. Let's see if we can find out where the problem is. Notice the ping is failing. So, trace cert, and notice there are various options here, but we're going to go for trace cert -D so that there's no resolution of names. 10.1.2.5. As you can see, the first hop times out. Our first hop or default gateway doesn't know about that route. So it looks like our router doesn't know about that route. So let's telnet to the router and make sure. So telnet 10.0.0.100, which is our router. I'll log in. So let's see if the router knows about the route. I'm going to use the keystroke Control L, which is a shorthand for the command display IP routing table. This will allow me to see the routing table on the local router. As you can see in the output, there's an entry for 10.1.1.0, but there's no entry for 10.1.2.0. The MSR doesn't know about that route. So rather than creating a static route, I'm going to show you how to configure RIP. To configure RIP, you type system view. You then type RIP and a process ID, which can be any number. In this case, I've made it 1. And then you use the network command and tell RIP to run on any interfaces that fall within that command. So in other words, all interfaces which have an IP address in the range 10.x.x.x will have RIP enabled on them. All networks on those interfaces will also be advertised. Now it's good practice to use version 2 of RIP rather than version 1. It uses multicasts rather than broadcasts. I'm also going to type the command undo summary to stop automatic summarization of routes. Please refer to the routing introductory videos for more details on the basics of routing. So that's all I need to do on the router. So on the MSR, I've enabled RIP. I'll do the same thing on core switch 1 and core switch 2. So on core switch 1, type system view, RIP and a process number. In this case, I'm just going to be consistent and use 1. Use the command network 10.0.0.0. I'm going to set the version to version 2. And I'm going to disable automatic summarization. So I'm going to type undo summary. So that's core 1 configured. On core 2, type system view, RIP and a process number, network 10.0.0.0, version 2, undo summary. So hopefully we'll now have full connectivity in our network. This is the router, so Control L will allow me to view the routing table. As you can see, we've learnt a RIP route 10.1.2.0. It was learnt via RIP. The preference is 100. And we learnt about the route from 10.1.1.101. So, on our PC, I should be able to ping 10.1.2.5. And as you can see, the ping succeeds. If I do a trace, hopefully the first hit should be the router. And this is something to be aware of. HP A-series routers do not allow trace route by default. So, on the HP router, you must type the command ipttl expires enable IP unreachables enable. I'll do the same on both switches. So ipttl expires enable IP unreachables enable. And on the second core switch, IP unreachables enable ipttl expires enable. And let's try and do that trace route again. So trace cert 10.1.2.5. As you can see, the trace succeeds. The first hit is 10.0.0.100. which is the MSR. The second hit is 10.1.1.101, which is core switch 1. And the third hit is 10.1.2.5, which is our PC. So we've successfully allowed our PC 10.0.0.249, which is connected to the Cisco router and in turn connected to the MSR, to connect to PC2. Now I'm running VNC on that PC. VNC allows me to remotely take control of the PC. So let's see if we can connect to the PC directly. 10.1.2.5. As you can see, I'm able to connect to the PC. I can open up a CMD prompt and I can type the command ipconfig. I can see that this PC has two IP addresses, 192.168.1.2 as well as 10.1.2.5. And that's the IP address we're concerned with in this topology. Notice the PC has the default gateway of 10.1.2.101. Going back to the router, you may have wondered why we're not seeing network 10.1.3.0 in the routing table. The reason for that is that the virtual interface 10.1.3.0 requires a layer 2 interface to be up before the interface can be up. So for RIP to advertise the network, the layer 3 interface needs to be up, and that in turn requires a layer 2 interface to be up. But if we look at core 2, display interface brief, notice VLAN 3 is down. The VLAN 3 interface is down because the only layer 2 interface associated with VLAN 3 is down. Notice gigabit 101 is down. If we type the command show VLAN, or rather display VLAN, notice there are two VLANs, VLAN 1 and VLAN 3. If we type display VLAN all, notice we can see that all of these interfaces have VLAN 1 associated with them. Notice please that gigabit 101 is not in the list. Scrolling down, we can see that VLAN 3 is associated with port 101. In other words, there are no tag ports and only one untagged port, 101. But that interface is down. So the VLAN 3 interface or virtual interface is not advertised. And hopefully shortly we'll be able to ping from our recording machine to PC3. So I've made sure that the cabling is good. On the switch, core 2, let's type the command display interface brief. As you can see, interface gigabit 101 is now up. It's running at 100 megabits per second. On our router, display IP routing table shows us that we now have a route 10.1.3.0, whereas previously that route wasn't in the routing table. On our PC, let's see if we can ping 10.1.3.5. As you can see, the ping succeeds. So let's trace to 10.1.3.5. So once again, the first hop is the MSR. Interface gigabit 00 with IP address 10.0.0.100. Second hop is core switch 2 with IP address 10.1.2.102. And the third hop is the PC. So in VNC, let's see if we can connect to 10.1.3.5. We have to enter a password. As you can see, I'm able to access the PC, IP address 10.1.3.5. So as an example, this PC could ping 10.0.0.100, which is the IP address of the MSR. So we've successfully configured the HP part of this topology. I haven't configured VLAN 3 on core 1 or VLAN 2 on core 2. That will become necessary when we add access switches to the topology and expand our network. So let's configure that now, which will be required when we expand our topology. So on core switch 1, VLAN 3, description, red, VLAN, interface VLAN 3, IP address 10.1.3.101 with a relevant mask. I'm going to save the configuration. On core switch 2, VLAN 2, description blue VLAN, interface VLAN 2, IP address 10.1.2.102/24. Save the configuration. So, on core switch 1, display interface brief shows me that I have 3 VLAN interfaces, VLAN 1, VLAN 2, and VLAN 3, with the IP addresses as per our network diagram. On core switch 2, display interface brief, we have 3 VLAN interfaces, VLAN 1, VLAN 2, and VLAN 3, with the IP addresses once again as per the diagram. Now, as mentioned previously, VLAN 3 is down on core switch 1 because there are no interfaces on core switch 1 in VLAN 3. On switch 2, there are no interfaces in VLAN 2. So let's have a look at the configuration. So on switch 2, display VLAN 2. Notice no ports are tagged and no ports are untagged for VLAN 2. On core switch 1, display VLAN 3. The same is true here. No ports are tagged and no ports are untagged for VLAN 3. The bridge aggregation, however, should be tagged for those VLANs. Let's check VLAN 2 on core 1 and VLAN 3 on core 2. Once again, the bridge aggregation is not tagged for those VLANs. Now the topology works because core 1 is doing inter-VLAN routing for VLAN 1 and VLAN 2. Core 2 is doing inter-VLAN routing for VLAN 1 and VLAN 3. So traffic from PC3 going to the recording machine will use VLAN 3 on the access port, will be inter-VLAN routed by core 2, sent across the bridge aggregation in VLAN 1, sent to the router or MSR, which will forward the traffic on to the Cisco router and on to my recording machine, which once again is connected via wireless. So at the moment it works fine, but when we expand the topology, we're going to have to fix this. We'll have to allow tagged VLANs across that bridge aggregation. So let's fix it while we're here. So system view, interface bridge aggregation 1. Now in this case we have to set up a trunk. So port the link type trunk, port trunk permit VLAN, and in this case I'm going to permit VLAN 1 and VLAN 2 and VLAN 3. So display this. Notice I could also have typed it VLAN 1 to VLAN 3. So those VLANs are allowed across this trunk. The native or PVID or untagged VLAN is VLAN 1. On core 1, interface bridge aggregation 1. Port link type trunk. Port trunk permit VLAN 1 to 3. Display this. Notice the configuration has been done. So now if we type display VLAN 2, you can see that it's tagged on bridge aggregation 1, which consists of physical ports 10 gigabit 1027 and 1028. It's untagged on gigabit 101, the port going to our PC. For VLAN 3, it's tagged on the bridge aggregation, once again ports 27 and 28. It's untagged on no VLANs. There are no ports in VLAN 3 on this switch. But if we type display interface brief, notice all the VLANs are up because an interface, in this case the bridge aggregation, is permitting VLAN 3. By the same token, on core switch 2, display VLAN 2 shows me that it's tagged on the bridge aggregation, in other words, ports 27 and 28. There are no untagged ports. VLAN 3 is tagged on the bridge aggregation and untagged on port 101. So that configuration looks good. I'm going to save the config. Save the configuration on this switch. Now the HP infrastructure is working, but can the PCs ping the Cisco router? Notice the recording machine is connected via wireless to the Cisco router, which is connected to the MSR, but the wireless and physical interface are bridged on the Cisco router. So the Cisco router in this case is acting as a switch. It has built-in Ethernet ports which allow it to act as a switch. So on our PC with IP address 10.125, can it ping 10.0.0.100, which is the IP address of the MSR connected to the Cisco router? So in other words, this IP address here, which is on the same subnet as the Cisco router. As you can see, the ping succeeds. Can it ping the Cisco router? And as you can see, the ping fails. You can see the request times out. So this PC is not able to ping the Cisco router. Can the switch ping the Cisco router? So on core 1, ping 10.0.0.254. As you can see, the ping fails. The reason why is the Cisco router needs to learn about these routes from the MSR. Now the MSR has already been configured with RIP, so have the two core switches, but has the Cisco router been configured with RIP? So, telnet 10.0.0.254, login. As you can see, I'm connected to a C857. Show version shows me that this is a Cisco router, and it's a Cisco 857 router. So, show IP route. As you can see, this router has some directly connected interfaces and a default route to the internet. It, however, does not know about the networks 10.110, 10.120, and 10.130. So, configure terminal, or conft, router RIP, network 10.0.0.0, version 2, no order summary, does the same as undo summary on an A series router, Control Z, show IP route. Hopefully we'll learn some RIP routes and be able to connect to the remote networks. There you go. You can see that we've learned 3 RIP routes: 10.130, 10.120, and 10.110. So ping 10.1.1.101 succeeds. 2.101, 3.101. So we can ping core switch 1's IP addresses. What about PC 10.1.2.5? We can also ping the PC. Can the PC ping the Cisco router? Previously it was not able to, but notice now it is able to ping the Cisco router. So RIP has allowed the Cisco router to learn about the routes from the HP MSR, which in turn learned about the routes from the core switches. Can the PC connect to the internet? So as an example, can I ping www.yahoo.com? At the moment, it doesn't work. What about on the other PC? So can the other PC ping the Cisco router? Yes, it can. Can it ping www.yahoo.com? As you can see, the ping request timed out. The issue is the routers have to learn about the default route from the Cisco router. So the MSR, as well as the two core switches, need to learn about the default route from the Cisco router. So on the Cisco router, show IP route shows me that the router has a static default route to the internet. So I'm going to type conft router rip redistribute static. This will allow me to redistribute static routes into RIP. I'm going to set a default or starting metric of 5. That means that that route will have an initial cost of 5 hops. I'm going to telnet to the HPE MSR. Display IP routing table. As you can see, the MSR has learnt about the default route from the Cisco router. Notice the next hop is 10.0.0.254, learned via RIP. What about the core switches? So Control L on core switch 1 shows me that we've learned a default route with the next hop of 10.1.1.100, which is the MSR. On core switch 2, notice we've also learned a default route. So on the PC, can we now ping yahoo.com? At the moment it's failing. Let's go back to the Cisco router and see if we can ping yahoo.com from the Cisco router. As you can see, we're able to do that. The IP address of Yahoo is 87.248.122.122. So can this PC ping that address? So can we ping 87.248.122.122? At the moment, the ping is failing. Let's see if we can trace to that address. So trace cert -d. As you can see, the traffic is sent to 10.1.3.102, which is core switch 2. It's then sent to 10.1.1.100, which is the MSR, and then it's sent to the Cisco router. It then times out. Now this is actually a NAT issue. On the Cisco router, I have to allow this subnet to be NATed. NAT is out of the scope of this course. Can the core switches ping yahoo.com? So on core switch 2, ping 87.248.122.122. As you can see, the pings succeed. What about core 1? So ping 87.248.122.122. As you can see, the pings succeed. Now I've adjusted the NAT statement on the Cisco router. Let's see if we can ping yahoo.com from the PC. As you can see, the ping succeeds. Just to prove it, ping www.yahoo.com. As you can see, DNS does a resolution and we're able to ping yahoo.com. So we now have full connectivity in this network. The devices can connect to the internet. All devices can ping each other. Now is a good time to expand the network to include HPE ProCurve switches. And this will prove quite nicely that we can integrate Cisco with A series as well as E series.